Okay, so let's first look at our first example here, where someone claims that the population mean, is equal to 40, and we're asked to test this with a level of significance of 0.05, and the population standard deviation is 1.97. And then we take a sample, compute the sample mean. It turns out to be 39.2, and the sample size was 25. We are going to say, I know that 25 is less than 30, so we're just going to assume that the population was normally distributed right here. So we'll assume that. We'll also assume that the sample is random. And we identify the claim. Well, it's here. It has equality, so it has to be the null hypothesis. And then the alternative hypothesis says mu is not equal to 40. And this is the claim. Claim is the null hypothesis. So this means that we're either going to reject the claim or there's not going to be enough evidence to reject the claim. All right, so next is what's our level of significance is 0.05, and we have a two-tailed test because unlike if this is true, unlikely values could be greater than 40 or less than 40. So we have a two-tailed test, which means we have two regions. Both of these regions have to add up to 0.05. So this region is 0.025, and this region is 0.025. And you can check using your tables or your calculators that this value has to be 1.96, and this is negative 1.96. You can take the inverse norm of 0.025 and you get this number. Then by symmetry, you can see what this number is. Then we use our standardized test statistic formula. This is going to be x bar, so that's 39.2 minus 40 divided by 1.97 over the square root of 25. Okay, on the calculator this turns out to be negative 2.03, which we can see is in the rejection region. It's certainly less than negative 1.96. So we reject the null hypothesis. Okay, but in our claim, what does it say about our claim? It says there's enough evidence to reject the claim. Okay, the last thing you always want to do is write a statement in terms of the claim, not H0. Okay, now next, if we look at this example, our claim has mu is greater than 499, so that's strict inequality. So that means our claim has to be the alternative hypothesis. So HA is going to say that mu is greater than 499, and this is our claim. And then the H0, the null hypothesis, is the complement of that, which says mu is less than or equal to 499. Okay. All right. Then this says that if we assume this to be true, our unlikely values for x bar would be greater than 499. So that means we're talking about a right-tailed test. Where this area, alpha is 0.01, so that's what this area is. And then we can use our calculator or our tables to find that this point has to be 2.326. Okay, you can use inverse norm of 0.99 or look it up on your table. Because again, this is just the standard normal distribution we're using. So now we compute the standardized test statistic. So it's 502 minus 499. By the way, we can assume that when we assume mu is less than or equal to 499, we can sort of just take mu to be equal to be 499. okay, and for our purposes of hypothesis testing. And then we divide by 10.6 over the square root of 100. And this turns out to be 2.83, okay, which again is in the rejection region. So we reject H0 again. And because we're rejecting H0, we can support HA, which means we can support the claim. So there's enough evidence to support the claim. Okay. Finally, let's look at this last one. Here, the claim has a quality in it, so it has to be the null hypothesis. That means HA says mu is less than 2.68, and the null hypothesis is our claim. We assume this to be true. Unlikely sample means would be less than 2.68. So now we're using a left-tailed test. And alpha is 0.05. Okay, we can take inverse norm of 0.05 and then we'll find that this critical value is negative 1.645. We compute the standardized test statistic, 2.60, that's minus 2.68 over 0.32 over square root of 30. This is negative 1.369. And this is not in our rejection region. Okay, because it's bigger than negative 1.645. So we don't reject H0. And since we're not rejecting the null hypothesis, we don't have enough evidence to do anything. In particular, we don't have enough evidence to reject the claim.